Welcome to the AWHI Commercial Working Group call. And we always like to encourage our members to collaborate freely with one another on different opportunities. So go ahead and put your name and contact info in the chat, and so other people can coordinate with you. And if you're new to the meeting, maybe say that also, and you know what you're kind of hoping to get out of it. Do you want me to take control and just click forward so you don't have to?
Yeah. Okay. Yeah, good for it. That's great. Good work.
Okay. So we have an antitrust compliance statement at the beginning of every meeting. I'm sure you guys are used to these. The Advanced Water Heating Initiative is a member-supported collaborative of professionals from across the United States. Our diverse membership includes numerous competitors, and care must be taken to scrupulously abide by federal and state antitrust laws. Members should remember that antitrust compliance is important at all times. At this and other AWHI meetings, participants should not discuss competitive pricing, profitability, allocating markets or customers, or promotion of a particular product or accessory. Okay. Any questions?
Just you said scrupulously very well. That's a tough word.
It's a nice one. Thanks. I like it. Okay, so our agenda today, I was just commenting to Joe, extremely aggressive, but many of these first items are in forms, and so I'm going to push hard on the timeline. And we're going to have, we did our antitrust. We have some updates on the advanced water heating specifications with NEEA and CEE. And then Jon Heller is going to be talking about a central heat pump water heater project that we're doing in Seattle. And in part, it's going to be looking at standardized MMV, like an MMV dashboard and load shifting. Noah's going to give us an update on the small commercial heat pump water heater field survey, which I've heard a little bit of, so that sounds exciting. Today, Nyle, Chris Ebener from Nyle is going to be our manufacturer spotlight. We also have another central heat pump water heater installation at Tacoma Power, Tacoma Housing. Vidhisha and Mesfin are going to be sharing all that, and then we'll close out.
We may go 90 minutes. We've got the 90 minutes booked, but yeah, if our aggressive 75-minute time doesn't hold up, yeah. Just FYI.
You hit me up at the chat if we're running behind. Okay, so anybody new to our group, please do put your information in the chat. Like I said at the beginning, we like to encourage a collaboration, and this is one way to start that easily and friendly behind a screen and put your information out there. Thank you. Anyone want to introduce themselves? Want to shout out? I've lost the chat, so I can't see that anymore. Okay, I'm going to move forward. We're ahead of schedule. Commercial heat. Oh, are you going to go with these slides? Do you want me to, Joe? You want to cover these, or somebody on your team?
Yeah, I'll actually I'm going to call on my colleague Susan Harris to give us a little update on this event. Susan, if you're on.
Yes. Hello, everyone. I'm Susan Harris with New Buildings Institute, and as part of my work, I focus on some aspects of the Advanced Water Heating Initiative. Coming up, we're going to have a special training. It'll be in San Jose, California. It'll focus on commercial heat pump water heaters. We'll have Evan Green from Ecotope, who will be presenting to the group about commercial heat pump water heaters, sharing about the technology, sharing about some of the installations. We'll also have multiple manufacturers with us. It's pretty special that we'll have several manufacturers of these pieces of equipment in one place so that people can see firsthand some different equipment for commercial heat pump water heater installations. We'll also have a virtual component, so if you can't join us in person, please feel free to join us online. I'll have a camera there to share Evan's presentation, and then we'll also have some video of the interactions with our manufacturers. We have more information on our website, including an event flyer that you could find more about the event. You can share it widely, and I hope you can join us. I'll put the link in the chat as well as being here on the slide. And please feel free to reach out if you have any questions. I'll also put my email in the chat. Thanks, Joe. Back to you.
Thanks, Susan. Yeah, appreciate it. And yeah, I'll just say quickly, this is part of Heat Pump Week. The Heat Pump Partnership is organizing a full week, April 11th to the 19th, all about heat pumps. And this will be a commercial heat pump water heater aspect of Heat Pump Week. So check that out. Great. A couple other quick agenda items. We've got the Hot Water, Hot Air Forum next week. And we just wanted to pass the mic. If anybody has any sessions to highlight on commercial heat pump water heating, there's a lot of good ones out there, actually too many to put on some slides. So if anybody's in the crowd, and we'll give you about 30 seconds to come on mic and promote your session if you have a good one or know of a good one.
Or put it in the chat.
Or put it in the chat, yeah, exactly.
Joe, are you presenting on anything?
Yes, I'm presenting on heat pump water heater performance, but it's more of a residential presentation. But there'll be lots of good. Vidhisha, do you want to say quickly what you'll be presenting on? Is that some more of a commercial?
Somewhat not commercial, but it's more focused on heat pump water heaters like central system as well as in units. So that will be in affordable multifamily buildings and manufactured housing. So looking forward to that one. So if you're around, do come and enjoy the session.
Great. Well,
make a pitch.
Yeah, go for it.
This is Adam Gage with NEEA. I'm presenting in part 3 of the 3-part series on commercial heat pump water heaters. And I'll be talking about specifications and innovation, and specifically 2 multifamily buildings where we conducted load shifting here in Portland and learnings that we had there. So perhaps interesting for this group.
That'd be great. Thanks, Adam. Renee, go for it.
Good afternoon, everybody. So we have a couple of folks with LG who are going to be panel session in the afternoon on Tuesday, talking about heat pumps, as well as the heat pump water heater. So we've got a couple of people with LG who are going to be there, and we'd love to talk with you and see you. Thank you.
Awesome. Thanks, Renee. Good to see you there. All right, in the interest of time, I think we'll move on. But yeah, please, let's make sure to connect. Lots of folks from AWHI and from this working group will be at Hot Water Forum and Hot Air Forum next week. So let's make sure we all chat and see and learn the great information. A couple other quick plugs, and then we'll get to our sessions. We've got a high temperature heat pump water heater manufacturer roundtable happening on April 8th. So check that out. You can register there with a live link. Flow Environmental will be one of the manufacturers, and there'll be a couple others. So yeah, be sure to check that awesome event out. We'll put a link in the chat as well. And then just wanted to announce, this is commercial central heat pump water heating adjacent, but NEEA's has a new fact sheet and updated website for their Hot Water Innovation Prize. You may remember that NEEA's been, since a design charrette a couple years ago, trying to understand how to make it easier for in-unit multifamily heat pump water heaters to be replaced. NEEA's been conducting this prize to create an affordable, easy to install split heat pump water heater system, and this prize is really moving along. AWHI is one of the sponsors of this prize, and excited for they're going to be announcing a winner likely this year. So lots of information there on that website, and a really cool graphic.
Yeah.
Okay, great.
So with that, I think that Adam and Ryan, you're both on. Do you want to give us an update on the advanced water heating specifications?
Yeah, this is Ryan. I can go first. Unfortunately, I'm unable to go on camera, but able to talk. So I just wanted to provide a quick update. Most of you have probably seen, or at least the manufacturers on the call have received a request for feedback, an industry comment letter from us at CEE in response to the released, updated, or at least proposed specifications and a revision to the CEE Commercial Water Heating Initiative. The kind of overarching theme of the revision is to take it from a heat pump engine specification to an overall commercial water heating system specification. So we've added a lot of different considerations for ancillary components like storage tanks and piping and controls that impact overall system efficiency. And this is really an aim to capture the total system efficiency from the point where the water enters the system to where it exits and goes into the hot water distribution system for the building. The letter was sent out on March 5th. There's a response due date of April 24th. However, we have a new and unique opportunity to have a discussion in person at the AHRI headquarters in Washington, D.C. coming up in just a couple of weeks. So CEE is hosting a meeting there at the AHRI headquarters on April 7th and 8th, where we're going to be talking about specification revisions to not just water heating, but also HVAC, including both res and commercial HVAC and res and commercial water heating. There's a lot happening in all of those spaces right now as it relates to standards and specifications. Along with the updated commercial water heating specifications, there's going to be some changes to the CE qualified products list, mostly some additional data related to the Energy Star final test method that had some data reporting requirements. So we've pulled those in and would like to represent those data points in the ultimate qualified products list as well. And that's where Adam comes in here to talk a little bit about the interactions between qualified products lists. Naturally, the market likes to see one qualified products list and a harmonization around that. There can be lots of confusion and issues with having multiple qualified products lists, especially if they aren't on the same basis. And so Adam and I are working together along with the rest of the kind of AWHI leadership to develop a strategy on harmonizing qualified products lists to make sure that we reduce market confusion. And so I'll let Adam speak a little bit to some of the NEEA perspectives on that. And if anyone has any questions or comments about the updated specifications or the request for feedback from CEE, now's a good chance. If you want to ask a question, I'm happy to answer it here. Also, I put my email address in the chat, so feel free to email me with any questions that you have. Thank you. I'll hand it over to Adam at this point.
Thanks, Ryan. Yeah, I'll start out just by saying that NEEA is a participatory member of the CEE Commercial Water Heating Committee and very much supports CEE's efforts in the initiative and specification that they have put forward. NEEA also puts out a commercial water heating specification specific to heat pump water heaters, the advanced water heating specification. We are also planning a revision of this specification this year, and CEE's forthcoming, well, I guess out or shared specification and QPL are very much influencing that revision on the NEEA side. So our goal is that the specification that NEEA puts forward would be complementary to CEE and not redundant nor confusing for the market. So as Ryan mentioned, we've been working together to best lay out what that looks like and again, ensure that there is harmonization and a reduction of complexity for the market for entities putting forward specifications and or products lists.
Okay, so this is an inform. If anybody has any questions, things they want to have considered, maybe you can send Joe an email or put it in the chat. And looks like you're going to have a lot of discussion at CEE coming up. So thank you. Is there anything else?
Yeah, just one last mention that I will be at the Hot Water Forum and Hot Air Forum next week. I'll be there for all 3 days. So if you'd like to set aside some time to sit down and chat there, I'd be happy to do that. My email's in the chat. Thanks.
Great idea. Thanks. And Adam, will you be there?
I sure will.
Well, then you got two people there you guys can talk to and get some more information. Thank you. Okay, I'm going to shift over to Jon Heller at Ecotope, talking about a study we have going on. Jon, are you there? I do not see Jon online.
Oh, he's bad. Okay. Well,
Do you
we
see him?
will,
I mean, I can cover it.
Yeah, do you want to cover it, or do you want me to try to ping him and we can go back to him later?
How about both? I'll give a 2-minute overview, and then if he comes back, you can do it at the end. How's that sound?
Okay, sounds good.
Okay. So several participants to this study. Bonneville was one of them, along with Seattle City Light and NEEA. And the study is looking at retrocommissioning, my words used, Jon may describe it differently, optimizing installed central heat pump water heaters that were part of the, I can't remember if they're part of the specification. There might be too much information. Never doesn't mind. The point is they're going to go back and see how they can further optimize performance, how the dashboard will help inform performance, and then also to demonstrate some load shifting. So this is a big research project. I think it's going to run about a year. And if Jon comes on, he can share some more information. I'm really excited about the dashboard monitoring piece. So more to come. Oh, we'll let Jon talk about that.
Okay, that sounds great. Okay. About the load shifting. Sounds good.
Yeah.
Okay. Well, thanks, Kashmir. That's great. Thanks for filling in for Jon, and we'll see if he's able to make it on later. Great. All right, let's go over to maybe.
This side's good. This side's good though. Let's just give people a second to read this slide.
Oh, yeah.
This is important, and one of the reasons I'm aware of this aspect is because we're looking in the Northwest in the Regional Technical Forum. Last time we met with them in developing a prescriptive measure, they were thinking about developing this measure based on the performance dashboard. And so this would give insight into what that measure, this study will give insight into defining that measure if they continue to go down that path. Okay, and then we'll have a prescriptive measure. Now, Noah.
Awesome. Yeah. Happy to be on and share some preliminary results. I've definitely talked about this study a couple times on this working group in the past, but this is really the first look at legit data, not just kind of an overview of sites. So super excited to share that here. One kind of caveat is that we do have a whole bunch of sites. We're already at 20 installed sites. We're going to be at 26 or 27 total. But this is just a subsample of the food service sites, so that can be kind of comparing apples to apples here. So next slide. Cool. So really just going to talk about M&V data. This is a collaboration with Ecotope. They've been the ones installing the actual M&V gear, which includes flow meters, power sensors, a whole lot of things there. And NBI is kind of managing the study, and we've done some analysis here. So next slide. Just wanted to give a quick site breakdown of the 7 sites I'm going to be showing y'all today. So there are 2 grocery stores, both located in California, as well as a sit-down diner, a homeless shelter with a full-size commercial kitchen that's in operation 7 days a week, a quick service restaurant in California, and then 2 more of the same type of quick service restaurants in Texas. So that's just a little overview. So it's quite a range, and they're all kind of defined under that same food service bucket. Next slide. Let's talk about our first one here. So I'm going to show these visuals for each one. And just to orient you, so let's start in the top left, looking at average daily power. I know some of those, the legend is kind of hard to read here, but all I want you to look at is the top line is going to be your daily power consumption curve. So that kind of follows roughly with what one would expect for a restaurant, or sorry, for a grocery store that's open for most of the day, where you have a bit of a morning spike. and then a late afternoon spike as well. And in pink below is electric resistance, which you can see is pretty minimal. Taking a look over on the top right side is daily hot water usage. And you'll see this for really every site, but although most kind of fall within a band, as you'll see, there are some kind of major outliers where some days just have a crazy spike of hot water use. And that's going to have a pretty big effect on electric resistance use and performance. And we're going to talk about that more later with some more in-depth analysis. And then lastly, over on the bottom here, just providing some COP figures, and that's going to be the green bar is what you want to look at for COP. So it's around a 2 for this site, which is, and just to clarify, it's an integrated 120 gallon heat pump water heater here. And yeah, so next slide. Then we're going to go into our second grocery store. I think once one slide for the metadata for that first one got cut off, but no worries there because these two sites are basically identical. What I want you to know for these two grocery stores is that there was a decent amount of waste heat coming through and plentiful air volume. So that's something that's definitely going to help performance. There were all these chillers in an adjacent room that was pretty much always left ajar. So some of that waste heat is going to leak into the large space that heat pump water heaters are in. This second grocery store ranged from 60 to roughly 80 degrees indoors. And that first grocery store that we just talked about sometimes even exceeded 80 degrees. So pretty solid operating conditions for the most part. I will note that there were two integrated water heaters here that were near each other. So that may have an impact on performance as well. Neither of them was being strained that much in terms of hot water production, considering they're rated at almost 200 gallons per hour for their first hour rating. And they were each only getting, tasked with 200 to 300 gallons each per day. So, not crazy high there. Next slide. And then that's just your kind of same charts here. So we can see quite similar performance to that first site, right around that 200% efficiency mark, which is pretty solid for a grocery store application with, not the highest draw. Next slide. We also had a sit-down diner site with outdoor compressors. So this is our one split system we're going to be talking about today. As you can see, the swing was quite a lot bigger for ambient temperature. It's located in Sacramento. I think this site is going to be really interesting to watch, and I'll come back and present more later once we have a true kind of like cooling season data for this site, because Sacramento can easily get up to 90 or 100 degrees for a lot of the year, and we have not gotten to see that yet. So bear in mind, this is performance data with slightly cooler ambient temps, and the coefficient of performance is still excellent. So super happy to be seeing that there. Admittedly, there is no electric resistance on this site. So therefore you're at, somewhat greater risk for hot water outages, but at the same time, you're going to have better performance. So bit of a trade-off there. Next slide. And you can see quite a different power curve for this site. If you look at the top left here, where since it's a diner, it's really just open for a select kind of few hours in the early morning into the early afternoon. So you can see that the compressors are no longer running whatsoever. So pretty different than our grocery store sites. Hot water use was also a lot more variable in this sort of deal, right? A little bit less predictable with different days having bigger rushes. And then our coefficient of performance, as I said, was quite high. And this just kind of accounts, there are 4 different bars here at the bottom in that stacked bar chart, because there are 4 compressors running simultaneously. Next slide. I wanted to talk about our quick service restaurants next. And these are all going to be pretty similar. I want to note that they're all going to be better performing than this particular one. The reason this one had a lower COP is because it had kind of uncontrolled recirc, which is not actually how it should be. For whatever reason, this site was using basically a continuous 3 GPM recirculation loop, which is going to keep feeding really warm to hot water back into the heat pump and kind of killing its performance. And as a result, we saw that performance is worse. So we really don't want to have that. These sites are supposed to have a quanta controllers where once the temperature in that recirc loop hits a certain deadband, it'll only turn on then. So that's kind of why we're seeing a lower performance here. Next slide. I'm going to skip through this. So next slide again. And so as you see, so this one had an aquastat recirc. It's the same type of quick service restaurant. And your COP is a lot higher, right? So 200 to 230% efficient, way better here. Funnily enough, it's actually way higher electric resistance use. So you would think that the higher the electric resistance use is, the lower the COP would be, but that's not actually the case here because the uncontrolled recirc is having a greater effect than electric resistance use. And this is a single integrated system, and it's having an average draw of about 520 gallons. So pretty darn high, especially considering that draw range can get all the way near 1,000 gallons in a day for a single integrated unit. So that's definitely putting a lot of stress on the system in terms of performance and resisting those elements turning on. Next slide. And I wanted to just show you here how you do, you can see in the right visual here, with some of those blue dots getting quite high, right? Some random spikes to about 1,000 gallons. And the other quick service restaurant in Texas has some even higher spikes up to about 1,500 gallons. Next slide. And this is the one I was talking about here. This site, I don't think we'll have a graph for it because there was a couple of data errors that we need to just clean up. But the electric resistance use got all the way up to 60%. And that's because some days it was literally 1,500 gallons of hot water use for a single integrated unit. So that definitely goes to show there was some undersizing happening here, leading to that very high electric resistance use. And that's the percent of total energy used by the heat pump. So even though it's pretty optimal conditions from an ambient temperature standpoint, plenty of air volume, you usually need about 3,000 cubic feet for these units. That was all met, but there was some undersizing happening, which led to a lot more electric resistance use. And that kind of makes sense in quick service because sometimes you will just have way more people going to a drive-through or whatever it is. So you kind of have to account for those demand fluctuations. Next slide. And just the last couple of minutes here, I wanted to talk about some cross-site analysis to try and break out trends from several different sites. Next slide. So let's first take a look at the hot water draw distributions. I'm only showing 4 of the sites here because those were the ones that had enough data at the time of this analysis. So I wanted to just give you another better visual sense of kind of some sites having more extreme outliers, meaning kind of these long right tails. For example, the grocery store in Vista, California, you have a lot kind of more variance in the distribution, and that can definitely affect performance as well and make it a bit harder to size these systems when they're less consistent. And that's really going to vary from subsector to subsector. Next slide. We notice a pretty distinct impact from hot water draw on COP. This is echoed by residential studies that have come out, for example, from Slipstream. They did a great 120-volt Midwest study that showed some similar results where you have a very positive impact on higher hot water draw means better COP. It's, of course, not super linear here, and the trend isn't really strong, but it's definitely significant. Next slide. And then we notice a similar but kind of less correlated, lower R value effect on ambient temperature and COP. So there's still a bit of a trend here, but it's pretty weak. And I think this is partially explained by not having that much temperature variance for 3 of those sites. So next slide. Big picture takeaways here. I just want to really hammer home that continuous recirculation, when it doesn't have any sort of control, is really gonna diminish the COP quite intensely. So really want to make sure that is being controlled. Integrated units in restaurants may be undersized, and that can reduce efficiency as well. And it will lead to a lot of electric resistance use. I did some separate analysis not shown here, but for integrated units versus electric resistance, based on real world data we collected, the payback period is only 1 to 2 years. And that's based on standard electric prices for the US average, which is about 15 cents per kilowatt hour. So your payback period would actually be a lot faster in places like California with very high electricity prices. As I noted, higher draw is correlated to higher COP, and then there's less clear of an effect with ambient temperature. Again, that's something I'm very curious to return to, especially for the Sacramento site, when we do see those 90 or 100-degree days, and see if the coefficient of performance can push into that 4.5 or even 5 COP territory. So definitely excited to share more. I'll be talking about this a bit at the Hot Water Forum, so hope to catch you there, and thanks for having me on.
Thanks, Noah. Any questions for Noah?
I saw a couple pings in the chat, so let me take a look. You know what? Those were, I think, unrelated.
Yeah, and the other thing I would mention, I was just putting this in the chat, that recirculation load destroys the system COP across many different types of
Yes.
heat pump water heater systems. So it's the same true for the multifamily research that we've been doing. So
Yeah, great point. And very true for single family homes too. I've heard some horror stories about insane bills. I think Joe's talked about this some too, but for single family homes, when you have that uncontrolled research, it kind of negates all the benefits of having a heat pump water heater, because heat pump water heaters and warm to hot water input temps just don't play that nicely.
and then Neil has a question.
And Amin has his hand up too. So maybe
Okay.
Neil first. Yeah.
Thanks.
Neil, you want? Neil's asking, what's your recirc control recommendation?
Yeah, so on the sites that I've seen, it's just using an Aquanta controller. Oh, sorry, not Aquanta, an Aquastat controller. So that seems to be pretty effective. We saw just for those kind of comparable sites, those quick service restaurants, that just having that control on and only having the recirc loop turn on once the recirculation loop water temperature dropped to a certain extent seemed to dramatically improve efficiency by, anywhere from 40 to 50%.
Great.
And research shouldn't be discouraged altogether. That's a great question. I think especially in food service, you need to have very hot temperatures coming out of your end uses pretty immediately for like sanitation purposes, right? So if folks are doing dishes, for example, they need to be able to turn that faucet on and have it immediately be hot. And if you don't have recirc, then that's not possible, right? And then you might be cleaning your dishes with cold water or waiting a really long time, and that can waste water. So there are trade-offs there, but I think it shouldn't just be a continuously reheating recirc cycle, because then you're always getting temperatures that have a very low delta from the input and outlet temperature for heat pumps.
Great. And then I think Amin, and then we should probably move on.
Yeah, thanks. I know a great presentation. And I had a question on the second bullet here on the integrated units in restaurants, maybe undersized. Can you speak to the percentage of runouts that you were seeing? That is definitely a health department concern. So it is a system COP issue, but yeah, can you speak to that?
From all the sites I spoke with, no one complained about runouts, but I did hear specifically for the split systems that water was cold in the morning. And that's kind of a separate issue, but that's more of a kind of a controls logic thing where sometimes when a restaurant hasn't been open and then they reopen it, the system kind of takes a while to kick back in. Again, that's for split systems. But I have not heard complaints about cold water. I need to do some separate analysis just looking at the outlet temps. But that's definitely a pending piece of analysis. Thanks, Amin.
Yeah. I'd be very interested in kind of that percentage of time that hot water is below like 120 or
definitely
below the set point. Those are some metrics that we're tracking and kind of trying to develop some a standard for. Yeah.
Yeah, no, great point. Yeah, because I feel like for single family, you always use that like 110 or so and see if folks are getting cold showers. So I'll take a look here at the equivalent.
Thank you.
Cool. I'll let Joe and Kashmir move on. Thanks, y'all.
Thanks, Noah.
Take it, Joe.
Well, we just wanted to, as we do, I think in almost every working group, welcome a manufacturer to come on and talk about their new piece of equipment. There's a lot of great equipment at the AHR Expo. One company I bumped into and then chatted with about coming on was Nyle, about a new product they're bringing to market. But I do want to just give a quick disclaimer that we, in this working group, we just provide this information as for informational, educational purposes only. AWHI doesn't receive any payment, free products, or other compensation for manufacturer spotlights, interviews, or articles, and we don't endorse or recommend specific products or brands. As hopefully most of you know, AWHI's role is to educate the market on developments in heat pump water heater technology, supporting informed decision-making and market transformation. So we try to extend the invitation to all manufacturers and hear about the latest and greatest innovations. And today we'll hear about Nile's. So Chris, I'll turn it over to you, and feel free to take control of the slides.
Awesome. Thank you, Joe. I assume you can hear me all right?
Yeah, can hear you great.
Awesome. Cool. And I'm just waiting for the consent dialogue here to show up. But I have a unique opportunity today. I had intended to take this from my home office, but I happen to be at the factory today. And on top of it, if I can do a little quick reversal for those that can actually see my camera here, the unit that we're going to talk about today is Nile's Velo product. And two of my engineers are actually working on testing this unit live fire right now in our factory. So I wanted to take an opportunity for people to see these things, because this is not something everybody gets to see every day, a unit of this size class running. But what we have on display here is Nile's most recent cold climate air source heat pump. This particular heat pump is driven by a 15 horsepower variable frequency drive reciprocating compressor. And if you can't tell, I'm giving a presentation right next to this thing while it's running full bore. It is very, very quiet. One of the unique features of this product, and something that was designed from the ground up to do, was fit through a 36-inch door and onto a freight elevator, all while using a pallet jack. But when we get into retrofits for large commercial buildings, multifamily included, we need a way to address that. And classic air source heat pumps usually have to be craned into position. And if you're going for a ducted application, it can be very tricky to get into the building envelope. This unit is designed to overcome that. So it currently sits at about 33 inches wide, which fits nicely through a doorway, even without taking it off its timbers. So very unique form factor. This unit is also zero side clearance. Again, back to that issue of retrofitting into an existing building. Space is always at a premium, even in new construction. We're always being asked, how do we make things smaller? How do we come up with less space, especially as we transition away from instantaneous gas-fired equipment and into heat pump technology. So these units are designed to be set side by side in true zero side clearance fashion. And the intake is on the back, the exhaust is on the top. And Joe, I still don't have control over the PowerPoint.
Sorry, I just took off the PowerPoint. I'm gonna reload it, but I wanted to give everybody a better view of the live.
Oh, you got it.
Yeah, here, let me load it right back up. 1 second.
You got it.
The presentation was so good that we didn't even want to look at the PowerPoint anymore.
Well, I just have most of this committed to memory, but it does help to have a visual cue here and there. All right. So on top of it, in keeping with Nile's traditional air source approach, this unit has no reversing valves or hot gas bypass to bleed heat from your domestic hot water for defrost. So this unit will utilize actually the world's first hydronic defrost in order to defrost its evaporator. So we've eliminated our traditional electric resistant elements in the evaporator and swapped it for a small hydronic boiler setup that gives you one single access point for maintenance, and is actually faster and more efficient, more balanced than our traditional setup. So this is by far the most efficient defrost we've ever developed, and from all of the testing and data we've seen, is the most efficient defrost available. This unit is capable of producing 160-degree hot water across its entire operating range, from 10 degrees ambient all the way up to 120 degrees ambient, no D-rate. Our product manager, Rob Brown, had a real nice smile on his face when he showed me the first D-rate table for this, and it was a flat line across the whole range. And on top of it, it can do it at both wide delta Ts for those single pass applications and at narrow delta Ts. This unit is a single SKU. It doesn't have specific hydronic limitations. It can be used for both multi-pass and single pass, and also it has been developed from the ground up and a single pass with return to primary, meaning no swing tank is required. This unit produces a high value per BTU. It's a very small footprint. And because of that variable frequency drive, with a 15 horsepower compressor, it has 75% of the capacity at 10 degrees of our 30 horsepower variant. So half the horsepower, 75% of the capacity. As mentioned, this unit is capable of single pass return to primary. So that swing tank is no longer required. And I know I'm going to have to run a little counterculture here to the previous slides. We want to handle recirculation directly with heat pumps. And we've developed our heat pumps to handle that. High entering water temperatures have very minimal impact on our efficiency. And we actually have published that data. We can verify it on our actual performance specs for multi-pass versus the single pass specifications. All right. This unit also leverages a high static ECM fan for ducting purposes. It's actually built into the unit inside the front shroud behind all of that really cool vinyl wrap with the dinosaur scales on it. There is a ECM plug fan in there. It produces about 4 inches of external static. So if you need to duct one of these commercial units from inside of a building or a parking garage, you're more than welcome to do that. It's also a full powder coated aluminum frame. The unit is salt spray rated to 1,000 hours. You can put this thing outdoors in just about any climate. The unit also possesses NSF 61, and we rate everything to the high temperature standard of NSF 61, not the cold water standard. So all units have been leach tested at 180 degrees. This particular unit, as I mentioned, is capable of making 160 across its entire operating range, and this unit is actually capable of making water that is hotter than that. So we want to make sure we're rating for the correct conditions that this thing will be seeing. On top of it, Nyle uses low GWP refrigerant A1 classification, R513A, in all of its units. This unit is no different. This gives us some unique advantages. Number one, not being an A2L means there are no specific requirements for this unit if you do decide to put it indoors, or specific access clearances, et cetera, related to flammable refrigerants. The unit is also available in multiple native voltages, no transformer required. So if you have 208 3-phase, 240 3-phase, and 460 3-phase, the unit is able to take native power and do that without taking a transformer hit. All right. So as mentioned, the unit was designed from the ground up to fit through a doorway. Kind of going around here to the front, you can see our director of R&D, Rosen Malchev, just working on it right now and in the seated position, but it will fit nicely through a doorway. We actually just put it outside my office last week. The unit is actually named after a velociraptor because it heats in packs. Thing is meant to be stacked side by side. So we'll see here in the image, we've got 3 of them, true 0 side clearance. We do offer removable side panels on even our 0 side clearance units because, well, we like technicians. They have the ability to access it. We like to make it easier on them, but it has been designed to be accessible from just the front and the back. You can actually see right now, they have it open. And this is the main electrical panel, which usually gets in the way of service access clearances, but they put it on a hinge door that enables direct access to the compressor and allows us to access it from the front, which is traditionally possible. Oh, thanks, Rosen. Gave me a flashlight right there. All right. So from a layout standpoint, as mentioned, all the important stuff is on the front and the back. We've got our electrical service panels, we've got our pallet jacks access on the front and the back. And then on the rear, you'll see the intake on the upper portion of the system to allow that air into a V-shaped evaporator coil. We've got our electrical, condensate, plumbing, etc., all on the back. On the top, you'll see that exit point for that ECM plug fan. And again, you got 4 inches of static, so just about any project you want to duct from, you're going to be able to with minimal duct sizing requirement. We also have the ability to not only forklift, but pallet jack from the side as well on this unit. So again, maximum flexibility for maneuvering inside those mechanical rooms and building types. As mentioned, this unit does not care whether or not it is a narrow delta T or wide delta T application. So traditionally, we talk about multi-pass and single pass applications. This unit is able to do both of those things with just a software tweak on site. But it is also able to do single pass return to primary, which brings the advantages of both methodologies, single pass and multi-pass together. Single pass being high delta T operation. You've got your tank stratification, allowing you to store more energy in a smaller footprint, and a very small efficiency gain by going wide delta T. And then you get the advantage of multi-pass, being able to handle recirc flow or recirc demands directly, and the same form factor. And I put up here a very large block of text, but what I like to say is Nyle tries to make this easy. We've covered all of the bases for the design professional to the contractor to make sure that you're not having to figure things out on site or come up with your own solutions to problems. The units are tested end to end in order to make sure that when it's shipped from this factory, it works exactly as expected. So every unit that comes off the production line here is tested. This is actually our end of line test station. Not usually meant for R&D, but they co-opted after hours. We're on the East Coast here, so we cleaned up about 20 minutes ago. But this, we're also going to cover a lot of other aspects of the system itself. So from a plumbing standpoint, again, I've already mentioned NSF 61, but the units have their own internal pumps. They have all of their own internal controls, check valves, control valves, etc. Everything that you need in order to make sure that you have essentially a water heater in a box. From an electrical standpoint, when we give you information about the electrical requirements of this equipment, because it has all of those things included, we also include all of the electrical draws. So you're just not having to worry about booster fans for ducting purposes. You're not having to worry about accessory pumps, heat trace, all of those other things that go into the actual operation of the system. They're all included inside the piece of equipment. On the mechanical side, we're going to provide all of the information you could ever want. We provide full Revit files on all of our units. So from a design standpoint, you're able to plug these things in and you actually know where all of the connection points are, ducting points, etc., access clearances. On the acoustic side, we do measure the sound on all of these units at a distance of 3 feet away, at a height of 3 feet on all sides. We'll provide that information for acoustic verification purposes. Again, this particular unit is one of the quietest air source units on the market. And then from a control standpoint, oh, go ahead.
We're almost out of time. I just want to let you know, and there is a question in the chats. People would like to know how that hydronic defrost is working. And, maybe the best thing to do, because I do think this is a very cool product and I'm glad you came and shared today. Take a look at the chat and see if you can send out some additional information specifications on this product and its use.
100%. I will go through, I intended to go through the chat after I got off here when I'm back at my desk, and I will respond to things in there.
Okay, thank you. Sorry to cut you off. Anything else you'd want to add?
No, you're fine. That's the last slide. So just want to make sure everyone knows we do produce everything in Maine. Many of our products are Build America, Buy America qualified for projects where that is important. We are here to support projects end to end. Our applications team, actually I've got Rourke sitting here doing testing right now. Our applications engineering team is made up of mechanical engineers. They support projects from inception, so from design all the way through startup and commissioning. So the same person that helped you specify your product, help you design it, is the same person that has to make sure that it performs the way it's supposed to. That's our level of commitment to these projects. Thank you.
Okay, Thank you. And since I'm on mic, I noticed that I just added my own question to sizing. How do we do that? So maybe we can get that information out also.
Of course.
Yeah, and I got to say, Chris, you are setting the bar high for our manufacturer spotlights. Right from the floor. So in the future, you've raised a very high bar for other manufacturers to follow. So thanks for that awesome presentation.
And Joe, you dropped
You're
the
welcome.
content. Thank you.
Nice
Nice work.
I'll get that loaded right back up here. Yeah, but thanks so much for coming on. Yeah, please do see the great questions in the chat, Chris.
I'll take care of it now.
Coming up next, we have Vidhisha and Mesfin talking about a Tacoma housing project case that was completed recently. So with that, take it away.
Thank you, Kashmira. Yes, we did get lost a little bit in the spotlight presentation. So that's my excuse in case we are not doing good with this presentation. But we'll try to cover up some technical as well as non-technical part of a project as to like what really goes behind in putting a project together, and then a discussion bit on the results part. So I have my co-presenter Mesfin as well with me from Tacoma Power. I'll be dealing with the non-technical part of this project, while Mesfin will do a deep dive with the results and explain some technical uncertainties that we came across in this project. Just to give, okay, I'll just take control. Just to give a little high-level overview, the study site was in Tacoma. It was a new construction, housing Hilltop. There were 2 units, the north and south building blocks, about like 137 units in the north side, 94 units in south. And there were multiple partners that came together to implement this project. Tacoma Power did the utility coordination. Tacoma Housing Authority were the owners for the multifamily buildings who helped us identify a lot of key pieces during the project implementation part. Sunrise Plumbing did the installation. HV Engineering Design took over the designing of the product. They used the EcoSizer from Ecotope. Ecotope did the commissioning and monitoring and verification, while New Buildings Institute put together the dissemination part of this project, the results. There were a lot of interviews that we did with the stakeholders to understand the perspective that goes behind putting the project together, some of the challenges, barriers, lessons learned, and if this has to be scaled in future for any other new construction, for a central heat pump water heater, what are the things one should take into consideration? We also had a very diversified funding model given the scale of this project. A good amount from the DEED grant. There was some regional support from NEEA for the commissioning part. BPA, Tacoma Power, putting together some more funding efforts to make sure that we could move forward with this project and also towards completion. I believe no one in this call would want to know like why and what this technology is about. So this was more like a formality slide, but just to do a little bit overview, and Mesfin will take in from here for a deep dive of the system configuration. There are different products out there in the market that could be used as central heat pump water heater. There were certain considerations, needs, and requirements, which I'll explain later on in the slide. And in all of those checkboxes, Sanco units fit well. We went ahead with the Sanco split heat pump water heaters for this project. We used them, we clubbed them together as a central heat pump water heater. Depending upon the occupancy in different building units, different number of heat pumps were used. For example, you could see like there were 22 heat pumps in the north side, and the south building had about like 12 heat pumps, and different primary storage volume. There were like 3 storage tanks, and also there are slight differences in the swing tank element. Sorry, not the swing tank element. The storage volume. I'm so sorry about that, storage volume. But yeah, all of this that to the bottom line is this new construction with the Sanco heat pump water heater, depending upon the occupation, we went ahead trying to explore how well this works for the occupants, for the hot water usage on a daily basis, and if there are any challenges during installation. But to do a system deep dive, I'd like to invite Mesfin and move on to the next slide for a deep dive into the system design configuration. Over to you, Mesfin.
All right, thanks, Vidhisha. So yeah, the slide that you see on the screen is basically the configuration of the central heat pump water system. which is typical for both buildings, for the north as well as the south building, that is. So as you can see, the system has 3 storage tanks and like 2 electric resistance water heaters that serve as both temperature maintenance and also backup for the heat pump water heaters. So the way this system operates is when there's a load, then hot water is drawn from storage tank number 3 that you see on the screen. Those tanks are basically like piped in series, so you can think of them as just like one huge tank. But yeah, the hot water is drawn from that storage tank number 3, and then simultaneously cold water from the city is fed into storage tank number 1 to make up for that hot water draw. And the hot water goes through the electric resistance tanks on the left side, the 2 boxes that you see, and it goes through that tank and then gets tempered to 120-degree water temperature at the thermostatic mixing valve. So the thermostatic mixing valve, I don't know if you can see the picture at the top left. It's got that white box and like the blue box. That's basically the controller. It takes in the temperature of the cold water as well as the mixed water as an input, and then it modulates the mixing valve to basically supply that 120-degree water to the load. The system also has a circulation pump, reserve pump. This is like a fractional horsepower pump, basically running 24/7 to keep the hot water circulation in throughout the buildings. And there's the heat pump controller, which controls the heat pumps in multiple stages. So like in the south building, there are 4 stages. Each stage has got like 3 heat pumps, and in the north building, there are I believe 5 stages, and then like the number of the heat pumps vary because the total number of heat pumps installed in the south versus the north building is also different. Next slide.
Thank you, Mesfin. I'll just take on this slide. So as I mentioned, we had like different stakeholders taking on different roles in the project. Some of the basic steps that goes into project implementation. So first was trying to put together an initial planning and design. HV engineering and the installers, they work closely to understand what could really fit in this new construction. There was a lot of brainstorming sessions because you do have a product, you do have manufacturer manual, you have all the points that are listed out in the manual, but still when you're on the field, there are certain things that might not work according to the manual. So it was very important for the design team to also take into a lot of consideration from field experiences of the installers to understand what would really work. Now, one of the best parts in the project was this being a new construction, space was not a very big challenge. Like in retrofit, like you have to do with whatever space is available. Despite that, but like you have good amount of space, the construction is there to begin, but still there were many things that they wanted to make sure that they hit the right checkbox when it comes to installation, given the spatial requirements. This whole process went about for a month. Moving forward, the designing team then went on to use EcoSizer to design the product. They had some of the questions like they had clarity on that, basically, like, what is available in the product, like in the market, what would really fit in this particular building, how many units they would want to use. So it was not a big challenge to sort of like identify the product at that particular time, given the market size, and also like to sort of design what would work. They also consulted the building design architects, energy consultants to understand like what would be the estimated energy usage given the occupancy of both the buildings, since it was like different number of units. Now that went on for another like 2 or 3 months. When the system installation began, along with commissioning, it went on about for like 8 weeks for the installation. The commissioning took about like another 4 to 6 weeks in total. So this was a really lengthy process, right from designing, understanding the requirement, getting the units, putting everything together and installing. But then we did have some learning curve during this whole process. We can put together a plan on paper. We can have really good Word documents and spreadsheet, but life would be much easier if it really worked out that way. There were some administrative changes, policy changes, tariffs increased. So what was initially estimated as a budget went a little overboard. Now that is something that was beyond our control. But then what is something that we could have control is probably factoring in a lead time. Like if you're estimating the storage tanks to come, say, within like 4 to 6 weeks, or say like 4 weeks, you probably needed a little bit of more, like 2 or 3 weeks of buffer time to make sure that in case something is delayed, the work does not get delayed moving forward. But in this project, that was one of our learning curves. Yes, some of the work did get delayed because the funding was delayed. They could not procure the particular part or product units. And sometimes we had the product, but something like a small equipment, like a system controller, it took more than 6 months, almost like 6 months to like sort of like come to the site. Also, when the system commissioning was being carried out, the expectation was to have it done parallelly along with the construction. But because of the delayed funding, procurement was also delayed. The commissioning took place after the construction was done. That led to a little bit of issues with connectivity and placement of equipment like sensors or wiring cables to capture data. And that also led to some data discrepancies eventually. Funding was also a bit of an issue because when something goes over the budget, you also have to look for additional funding to make sure that you're able to move forward with the required units. Because given this is the multifamily unit, you cannot go lower than what you had already like put together as a plan. Like if you wanted 22 heat pumps for this particular north building, that is what is expected to like be there. So yes, these were some of the learning curves during the like sort of like project implementation pre-installation period, which some of which were beyond our control, but some of which we could have controlled. And if this has to be scaled, probably this is something that as a building owner, installer, program implementer, you might want to consider. But based on this, we also talk about something that happened with the performance of the product, like how well did it work for the north and south buildings, and also how much of this building was actually occupied. So I'll let Mesfin talk about some technical results here. Over to you, Mesfin.
All right, thank you. So yeah, the results that we're going to see on this slide and the following two slides is based on data collected from end of April 2025 until mid-November 2025. So we're talking about like 6 months worth of data that we have summarized in these slides. So like all the pie charts that you see at the top, the two pie charts, they are for the north building, and the bottom two are for the south building. So basically, what we're displaying here is energy consumption on the left side, and then hot water load on the right side. As you can see, energy consumption of the heat pump water heaters is roughly like 66% for the north building, and the corresponding energy usage, the corresponding hot water load that was covered by by that energy usage is 63%. And you can also see a roughly higher energy usage by the heat pump water heaters compared to the swing tanks / the temperature maintenance tanks in the south building, which is at 71%, and that corresponds to like 69% of the load covered in the south building. So there is a variation in, I mean, despite these buildings being located in the same, pretty much like in the same geographic location, there's variation in terms of like the the energy usage by the swing tanks, between the two buildings. And the primary reason for that is we think it's because of the occupancy level difference in those two buildings. So the north building had pretty much like it was not like fully occupied until like mid-September, like early October. versus the south building was like fully occupied, and then that we believe caused the need for like more circulation of hot water in the distribution loops in the distribution system, and that's causing the higher temperature maintenance load for the north building compared to the south building. Next slide. So the charts that you see on this slide is basically the same information that I discussed in the previous slide, but we're looking at that information like split up like on a month by month basis. So like on the left side is the north building, and on the right side is the south building. As you can see, like like the first bar in each month, the first bar is the load versus the second bar is the energy usage. And generally speaking, as you can see, like as we get closer to the hot, like the warmer seasons of the year, like during the summer season, there is, relatively speaking, there is like a lower hot water load, which corresponds to like a lower energy usage overall, by the both the domestic hot, both by the temperature maintenance as well as the heat pump water heater systems, and that is true like for both buildings. Yeah, next slide. So in this slide, we're presenting the energy usage versus coefficient of performance values that we observed in each building. And that information is split up just like the previous slide, month by month, and we're looking at the light green bars are basically the heat pump water heater COP values, versus the red bars are the system COP values. And as you can see, the heat pump water heater COP values are like, close to, I would say like 4, but roughly between like 3.5 and 4 for the north building, and pretty much similar values were observed in the south building for the heat pump water heater COP values. And that is, I think that's pretty much consistent with what's been reported on the product specification for this product, which kind of like puts it in the range of 3.5 to close to 5, depending on the ambient temperature that these units are operating. But when we look at the system COP values, you should, we don't expect to see as high COP value as the heat pumps COP, and that's because the system COP obviously considers various losses in the system, including like from storage tank, and then there's like temperature maintenance is also factored in that calculation. So those kind of like pull the system value down to to the range of like 2.5 to 3.0 for both buildings. So the overall system COP value that was calculated for the north building based on this data set, like the 6 close to 7 months worth of data set, is around like 2.65, and similar COP value was also observed for the south building. And the additional information that I want to provide as lessons learned from this project is, as you can see, the system COP values are not up to what NEEA expects for this type of system to have so like the NEEA's system COP value for this type of product is close to 3.2, but we're seeing much lower values. And some of the reasons we think for that include, one, there is a lack of swing tank balancing in this system. Like when the system is designed, it does not have a balancing valve to basically like restrict the flow that's going, the flow of the return water that's going to the swing tanks. And that's creating like a lot of temperature maintenance load that should not necessarily be there. And that's kind of like one of the reasons why we think we're seeing lower COP values in both buildings. The other reason that we think we're seeing lower system COP value is because of, in the case of the North building, it's because of the occupancy levels being lower than what they should be. So like once occupancy is fully, like once the buildings are fully occupied, we think that also will contribute to kind of like improving the system COP values. And the other reason that we think may have contributed to these lower system COP values is there's also like a lack of reserve flow balancing. So in these systems, like the balance, like the reserve flow is basically balanced manually, and they have got that constant speed pump, running water, creating basically like uneven circulation of water, and also like excessive loss of temperature in the distribution system, and that's causing like a lot of and that's causing unnecessary load like on the temperature maintenance tanks, which in turn will result in lowering the overall system COP values for this project. Yeah, that's basically what I have. Vidhisha, you can take it over from here.
Thank you, Mesfin. I'll also add that we did face calibration issues with the flow meter. So I think the first month and probably almost into the second month of the data collection, there were some data discrepancies, like we were getting negative data. So that also added to this whole overall data collection or data quality of the project. And as Mesfin mentioned, yes, the North building was 50% occupied compared to the South building. That added to, I think, a lot of times the resistance to kick in than the heat pump water heater mode, given the hot water usage. But then I'm just going to quickly wrap this up. We're almost on time. Lessons learned and some takeaways from this particular project. Diversified funding model is crucial. You cannot always be dependent on one big chunk of, like, say, a federal funding or some other local funding, because in case something happens and the funding gets slashed down, the project will be impacted, and you cannot leave the project midway. So it's better to have diversified funding model to ensure that different phases of the project are stable and they're able to connect the dots and move forward. State and local policies also are very crucial in implementing a project. Like if they really support electrification projects, if there are incentives, local and utility incentives for these whole home electrification programs, or for like central heat pump water heaters, it does add value in the means that it also helps financially. So that is also crucial for implementing a project in a particular area. Yes, there are some recommendations given the monitoring and verification to follow the qualified product list from NEEA's advanced water heating specifications. Also in this project, although I'm not going to do a deep dive, probably Jon Heller from Ecotope or Mesfin could answer this. We did reduce the set point, which was, I think, from 140°F to 130°, to eventually make sure that the system operated more efficiently and did not go into a resistance mode again and again. With monitoring and installation, it is important to have the system commissioning equipments installed during the construction to make sure that the sensors are placed at the right, because placement is crucial. The place at the right place, there are no network connectivity issues, and this does not hamper the data collection. And that's how you probably would come to know, like, how much energy savings we are making, or how much we are going to save on our utility bills. Also, it's very important to have a proactive maintenance plan. It's not like you have installed a system and your job is done. You also need to have a maintenance plan set along within the budget of the project to make sure even after the project completion, the installation completion, there is a maintenance plan and a certain budget and a team that will carry on this work forward, like, say 6 months time or 1 year time, because this is something that's often overlooked in different projects. Also based on some of the interactions that I've had with other housing authorities, they never had a plan beyond the project installation. Like, what do they do after the system is installed? How do they train their in-house plumbing or contracting team to make sure that they know how to maintain a central heat pump water heater system or an in-unit heat pump water heater system. There was other important piece of information that came up during this project was the automated alarms in case it was going into the resistance mode if the temperature was dropping too low. But this alarm happens to be like a light bulb, which was not very effective for someone to know that something was really off with the system. So it's better to have an enhanced alarm system so the commissioning team or the installation team or the plumber or contractor would know that something is not working properly. They could have a look at it and make sure that things are fixed on time. So yes, do factor in lead times because that is crucial in projects. It does happen that sometimes funding gets delayed, contracting gets delayed, and it's difficult for the contracting team to float the cost when the delay could be as much as like 6 months to 1 year. So that is some of the learnings that we had from this project. If you have any questions, you can drop them in the chat. But we'll be talking in depth more about this at the Hot Water Forum. So in case you have missed the presentation today, not to worry, we'll see you next week. But that will be all from my side and Mesfin. We appreciate your time and patience. Thank you so much. Over to you, Kashmira.
Thank you so much, Vidhisha and Mesfin. That project was a long time in the making, so glad to see things are turning out pretty well. We do have Jon Heller who has joined us, and I'd like to go back to his slides. If you have control, Joe, do you want to take it back to the top of his presentation? And Jon, we added more time to the meeting. It was set to end at 1:15, but we have the full 90 minutes. So go ahead and share the findings and yeah. Are you on?
Will do. Thanks, Kashmira.
You're welcome.
And thanks for the previous presentations. And I apologize, I was late, so I'm out of order. But I'm giving a preview to a project that is in the works. It's not fully contracted yet, but it's heading that way. Hopefully we'll get started in April on this. But am I able to, can somebody click through the slide? There's some bullet points that'll come up.
I'll take control, Jon.
Okay. So what we're finding with these systems is that without performance feedback, we're having some problems associated with being able to optimize the systems while they're being commissioned. It's difficult to maintain system performance over time. We see a lot of the performance slipping over time because things happen. And as long as hot water is being delivered to the occupants, nobody knows that the system isn't as efficient as it should be. So without performance feedback, you can't figure out why that might not be the case. And then when we're talking about trying to implement load shifting without performance feedback, visibility into the cycling of the heat pumps and the temperature maintenance tanks, we can't tell whether or not it's actually following the right controls. So this project that we're embarking on is figuring out how can we simplify and standardize and minimize the cost of adding performance feedback and load shifting controls so that they can become standard with these systems. And if you click to the next slide, this is just showing an example of the type of performance feedback that we're looking for. And click one more time, it kind of highlights that load shift period that we're trying to stay out of. And this type of data feedback provides a service to the utility that might be incentivizing a high efficiency product to verify that it is actually functioning at high efficiency, and that it's if the load shifting capability is being incentivized, that it's actually able to load shift. It's provides value to the owner because they can see that what they paid for they're actually getting. And again, if they're on a time of use rate schedule for their electricity, that they're seeing that they're able to not run their system during the most expensive electricity times. And then it provides a lot of service to the maintenance contractor to be able to visualize how the system is operating and anticipate what times when maybe the filters need to be cleaned, there might be a refrigerant leak or other problem with the equipment, and they'll be able to diagnose that with this type of feedback. One more click. And yeah, you can go ahead and click through those. And so the project goals are to install this EcoDash performance feedback dashboard on 7 to 10 existing projects in Seattle City Light territory. Provide the dashboard and alarms and fault detection capabilities from that data feedback. Document the existing conditions and quantify any savings available from retro commissioning with the data collected, and then shift the operation of the equipment to respond to City Light's time of use rate schedule and quantify the savings, both the kilowatt and kilowatt hour savings during peak times for the utility, as well as the dollars savings for the building owner by shifting the operation from expensive electricity to inexpensive electricity. And then we're trying to figure out through doing this at scale, how do we minimize the M&V and sensors necessary to meet the advanced water heating spec M&V minimum requirements and provide the level of performance feedback needed to accomplish what we're trying to accomplish here. Demonstrate a pathway to minimize the cost of that M&V, and then hopefully this all points the way for utility programs to begin to incentivize both the energy efficiency that commercially pumped water heating systems can deliver, as well as the load shifting, load flexibility that these systems can deliver. That's my
Thank
story.
you,
I did it in 3 minutes.
Perfect. Any questions for Jon?
Kishmir, this is Tony.
Mhm.
I just want to add that this Seattle has the unique situation that heat pumps is code, and these systems were installed as part of code, so they had zero utility touch. That's a fairly unique situation and allows for kind of a new baseline. So all the things Jon said, but in addition to that, we have that. Correct, Jon?
Yeah, and I would highlight that, yes, heat pump water heaters are code in Seattle, but it's not code that they have to work well.
Yeah.
And so what we're trying to do is develop a methodology that we ensure that these systems work well. And then our argument is that City Light can incentivize high-performing heat pump water heating systems, even though a code minimum low-performing system is required. They could incentivize the difference. There's a question from Chris Badger about asking me to connect the dots between EcoSizer, EcoSim, and EcoDash. Yeah, so EcoSizer is the sizing tool that is designed to allow people to balance thermal storage capability and the heat output of the heat pumps to figure out how big of a storage tank and how big of a heat pump do I need to serve the particular load at the worst case day. The EcoSim has now been built into EcoSizer. There's a new version of that out there you can take a look at. But the EcoSim is a performance simulation tool. So if we have the performance map of the particular heat pump that's being used, how it functions over different entering air temperatures and different entering water temperatures, and we have a assumed amount of hot water demand from a multifamily building, we can predict how that heat pump is going to function over the course of a year. That's how we are estimating the system COPs that are listed on the NEEA's qualified products list. And then EcoDash is that dashboard M&V that pipeline that I showed on the second slide, that's an example of the type of data that EcoDash makes available. It includes some standardized calculations for calculating system COP and so forth. It includes some automated alarming if you're delivering low temperature water to the occupants, or if the heat pump's not running when it actually should be, things like that. And has some other really good features that help diagnose issues and report performance.
And John, we do have a couple of people from Seattle. Well, you can see the chat that Phoebe is on the line, so I'm not sure who else is.
Tristan, I just noticing Tristan has his hand up.
Yeah, just a quickie. So it's super interesting about the idea that, hey, when systems get installed, they should really be monitored. And all of these systems are more complex. You know, I was recently in a building with gas boilers and they just flare on. And in the gas world, there's almost no time of use or anything. So none of it was necessary. But all these electric loads, we're working, you know, with a building in Portland that had a huge battery and solar installation, and nobody could see what the battery was doing. The vendor promised massive savings, and yet they had no context around not only the time of use, but it turns out half the peak demand charge, it was a peak in any time in the 24 hours. So they were loading on an 80 kilowatt peak building. They were loading the batteries at 120 kilowatts for 2 hours and creating new peaks every day. So I'm just promoting, everybody should realize that all of our electric loads there's lower and lower cost, low cost cellular monitoring, and it's starting to be really important to help building owners reduce their bills, let alone be prepared for DR.
Yeah, thanks for that, Tristan. And so the idea behind this study will be, how do we make that as simple and as standardized as possible for these systems?
Awesome. Yep. It's a new world that we need to deliver on because people are frustrated that things are invisible.
Good comments. Any other questions? Okay, well, with that, everybody gets, oh, Chris has another question. Chris, just in time.
John, just a quick follow-up. We had opened up a recent version of Ecosizer and noted that there was a new utility cost tab, but it seemed to be focused on the Northwest. So my question was a little bit leading and wondering, is that going to be expanded out to other parts of the country? And notably, we're just looking at opportunities in Hawaii right now. And just,
it can be. The reason it's just focused on the Northwest is that was funded by Bonneville. So it covers all Bonneville's territory, but it could be relatively easily expanded to other areas. We just need to get the
Hey, John,
get the weather files and so
we'd be
forth.
happy to raise our rates if that can help the issue.
Not appropriate.
Yeah, so it would be nice to expand that to the rest of the region. There's some other things to do with Ecosizer we've been working on and looking for one more small funder to add a return to primary and multipass capabilities to Ecosizer. I've thrown that out to several potential funders and nobody has bid so far, but it's a tool that's needed by the industry. If anybody's got ideas, let me know.
Hey, if we all just give a little bit.
Exactly.
Okay, well, with that, we'll give 1 minute back to everybody. So thank you for joining us again, this wonderful Advanced Water Heating Initiative meetings, and I hope everyone has a good day. Thanks to all our speakers.
Thanks, Kashmira.